Welcome back. I'm now on question number 8 from the IGCSE Cambridge paper 2 February-March 2022 0580 paper, and this question here is about transformations. It says, on the grid draw the image of the triangle A after a reflection in the y-axis. Okay, so here's triangle A, this one that's shaded, and we've got to draw its reflection after a translation in the y-axis. Okay, now, so it has to translate in the y-axis. The y-axis is this axis, the vertical axis over here, which is the line x equals 0. This is the y-axis. We've got to draw the translation, the reflection of this in the y-axis. Okay, so when something is reflected in a line, then basically the distance of a point on one side of the line and the other side of the line is exactly the same. So the perpendicular distance of this point from the line is 3 units to the right, so its reflection will be 3 units to the left. So it's going to be at this point here. So that point will reflect to this point, and this point will be, it's one unit to the right, it's going to be 1 unit to the left, and this point is 4 units to the right, so it's going to be 4 units to the left. So when I join these 3 points together with a straight line, I will have my reflection. Okay, so that's going to be the answer to part 1. Okay, so there's the answer to A part 1. So what I'm going to write here A part 1, just to make it clear that that's my answer to A part 1. Then it says triangle A after a translation by vector -3, -4. So every point on A is moved 3 spaces to the left. -3, -4 is a vector. It means 3 spaces to the left and 4 spaces down. If this is positive, it means to the right. If this is positive, it means up. This is 3 to the left and 3 down. So every single point, this point, for example, moves 3 spaces to the right and then 4 spaces down. So it's going to end up over here. That's going to be that top corner there. And then we can do here. We can do the same thing for this. 3 spaces to the right and 4 spaces down. So it's going to be down here. And the same with this one, 3 spaces to the right and 4 spaces down. So it'll end up in these 3 points, these 3 corners. And you can see to get from here to there, you've got to go 1 across and 3 down, 1 across and 3 down. From here to there, you've got to go 2 across and 4 down, 2 across and 4 down. So in relation to each other, we've got them in the same relative position. So that's just a little check in case you want to make sure they have to have, whenever you do a reflection or a translation, the shape and the image will look exactly the same, except for the translation will be exactly the same and the same way up. For rotation, for reflection, of course, it will be like reflected, okay, inverted, reflected compared to each other. So this is the answer for A part 2. So I'm going to just put a little label here, A part 2, so it's very clear to the examiner that which is which, you have designated as which. So there is the answer to question 8A, part 1 and 2. Then it says, describe fully the single transformation that maps A onto B. So if you want to go from A to B, we can see that B is smaller than A. For sure, it's smaller than A. So it looks like it's going to be an enlargement. That's the only type of transformation that we deal with, which deals with things which have got smaller or bigger. So what you do is, for an enlargement, you need to mention 3 things. 1, that's an enlargement, which we just determined. 2, the center of enlargement. So we're going to find the position or the coordinates of the center of enlargement. And to do that, you join together a point and its image, and you follow that line back. So just have to be accurate about this. You get a ruler and do it properly. So I'm joining the point and the image of the point, and then I do the same for another point. So I'm going to join this point with that point and follow the line back. I can see that they both meet up at this, and even with the third point, you see they should meet up. All should meet up at the third point. You only need to do it with 2 of them, but all 3 of them have to meet up at the same point. Now that is the center of enlargement. That point is the center of enlargement. Okay, so we can say that this is an enlargement. That's one thing we mentioned. That's the first thing. That's not fully describing it. We have to also mention what the center of enlargement is. The center of enlargement. Okay, and oops, can't spell. Center of enlargement is 9, -1, And then you've got to give the scale factor of enlargement. Now the scale factor of enlargement is how much bigger the image or the object is compared to the original. Now A onto B. B is the image. A is the original, so it's got smaller. Okay, the object has got smaller. So you always take a length of the image. Okay, the length of the image divided by a length on the object. Now we don't have any lengths directly, but I know, for example, I know that the length of this line is basically this line from here to here is like, this is the vector going from 1 to 4, which is 3, and then up 1. Or let me choose one that's a bit more, let me choose this one from there to there, no fractions involved. That's going to be 2 and then 5. Well, there is a fraction involved, doesn't matter. That's 2 and then 4, sorry, there's no fractions. 2 and then 4. So if I go from this point to this point, this vector here, this vector is 2, 4. Right? 1, 2, 1, 2, 3, 4. And the corresponding line on this shape, the vector from there to there is 1, 2. And we know, we can see that for you to get from 2, 4, you have to multiply it by a half, and then you're going to get 1, 2. So the length on the image is like 1, and the object is twice as big. All right, so this line here is twice as big as this. So the image over the object, this is the image over the object, it's 1 over 2. Okay, this vector is a half that vector. So the scale factor of enlargement, the scale factor is equal to a half. Okay, because it's always the image over the object. So that's how you get the 3 marks, full 3 marks. You have to mention the scale factor. In most cases, you can measure a line on both of them. Here we can't really measure a line on both of them. So what we've done is we've taken like a diagonal line and thought about its vector 2, 4, and the corresponding line is 1, 2. So we can see that this vector is half the vector of the image. Length on the image is half the length on the object. So that's how we can deal with centers of enlargement, and scale factors of enlargement. If you just say enlargement, you won't get the full marks. If you just give the center, you will get 2 marks, as well as 1 for enlargement, 1 for center. You must also mention the scale factor to get all 3 marks. Okay, so the scale factor is a half. If it got bigger, if the object was bigger than if the image was bigger than the object, then it would be a scale factor of 2. All right, so that completes this question number 8 from the February-March paper of 2022, paper 2 at IGCSE from Cambridge. If you would like to watch the other questions from this particular paper, you can subscribe. You can click on this playlist that will show up over here. The link down here will take you to the playlist, which is all to do with transformations, and then you can subscribe to the channel here if you wish to. Thank you for watching, and see you soon.